Without any further delay, coming to tonight's session on the data science, machine learning workflow, and role of product managers. Let me give introduction to our acclaimed and admired speaker of tonight, Mamtaj Narain. Mamta is a product and business leader focused on solving customers' problems using artificial intelligence and machine learning. She has held many different roles over 2 decades at Merrill Lynch, Fry, PayPal, eBay, Kohl's, and HP Enterprise. These experiences have given her first-hand understanding and appreciation of how technology is continuously disrupting business models. It also motivated her to embark on her next mission to evangelize and promote data science, machine learning, and AI to young minds and the non-tech community, and she launched realworldai.co, which is focused on driving awareness and education on AI ML for the non-engineering community. Mamta's motto is be brave enough to fail at something new. What a great thought, Mamta. And with that note, a very warm welcome to you. We are absolutely thrilled to have you here with us tonight. Handing the session over to you now.
Thank you. Thanks. Okay. Can I share my screen now?
Yes.
First of all, welcome everybody, and thanks for taking the time to attend this session on machine learning process and the role of product managers. So a little bit about myself. Shama already went over it, but just to double click on it, I'm a career product leader, have held variety of different product roles in different companies, ranging from platform product management, core product management, AI innovations, or product innovations. And all of these experiences really helped me hone down what is it that I'm really passionate about. And the passion that came through was I want to evangelize and promote data science and help small businesses actually implement AI so that they can see the real value from AI. So in this webinar today, as Shaman mentioned, the topic of the webinar is the machine learning workflow and the role product managers play in it. And all of you, I'm assuming, have gone through some sort of AI or ML, either a webinar or a course, or have just tried to educate yourself. At the same time, I'm assuming many of you are very familiar with what product management is all about, and some of you may be product managers. But one of the things that I see in the industry is kind of missing, or there is a gap, is what is the role of product managers in this new world of AI and ML? And how do we who are career product managers, or even who are joining new in this industry as product managers, pivot and change their thinking when it comes to AI and ML? Where is their importance the most, or where can they make an impact the most in this life cycle? And where is it that they have to collaborate, or they need to, be in lockstep with other cross-functional teams? So that would be a focus of this webinar, kind of a hybrid where I take you through the whole machine learning life cycle, but continue to double click upon what is going to be the role of a product manager in that phase. I hope that is in line with your expectations. If there is any question, please feel free to put it on the chat. Okay, so what I'll just start off with, what is a reminder of what is a role of a product management or a product manager? Steve Jobs, the famous saying, you have to start with the end in mind, or you have to start with the customer experience and work backwards to the technology and not the other way around. And what I'm seeing in the industry, and you all must have seen as well, with the advent of AI and machine learning, the new goal has become let's implement AI or let's implement machine learning. And then we work backwards on, okay, what problem can it solve? I would suggest as product managers or as business leaders or otherwise also, always have the customer experience or the problem in mind first, and then go and see if AI and ML is the right one to be used. And then the next code, the role of product manager is to discover a product that is valuable, usable, and feasible. Once you have identified that problem statement, You again need to double click and say, okay, if I'm going to implement AI and ML, is it going to be feasible? Of course, as product managers or business leaders, we'll always be focused on, is it going to bring value to my customers? Then let's move over to machine learning. Not about what is machine learning. I'm not going to get into the very foundational concepts here, but I actually want to take a tangent approach to machine learning on what is the goal of machine learning. We know machine learning is about machines learning on its own, or computer learning on its own through data and algorithms, so that you don't need to program for it. But why are we doing it? What is the goal behind it? So simply put, the goal of machine learning is to simplify a large amount of data down into a single decision or prediction. If you think about it, all of the complex work that is being done in the AI and ML space is really being driven by this just one single goal. Can it make a prediction? Can we make a decision? Can we classify something? Can we find something? So this gigantic amount of data is being processed and being analyzed by computers to get to that single decision or prediction. So that is really the goal of machine learning. So what does this mean for AI product management? Simply put, solving customer problems using data and enabled by AI and ML. In the past, data was mostly used for analytics, where once your product is launched, you will run some data reports, you will do analytics, and you'll find some insights. Based on that, you will go back and program something and create products. In the world of AI, we actually start with data. We will try to find out, given the data that I have today, what sort of problems can it solve? Or if I have a problem, and this is where the product manager's focus should be, if I have a customer problem, can AI and ML solve it? And then do I have data to solve that problem? So that is where this little shift happens. But then it comes with its own sets of challenges. And this is generally overlooked, or we don't um, pause to focus on the challenges that AI and ML is bringing in the product management world. And hence, many times we are also unable to explain why are these challenges becoming a showstopper for getting funding or getting the resources or getting the talent. So let's say, what is the challenges that this poses, like the AI product management? The number one is ambiguity of outcomes. And what I mean by that is deterministic versus probabilistic approach. If you think about it, in the past, in the traditional product management world, we are very used to selling one or zero. Computer programs is all about binary one or zero. You will tell your, let's say, a simple website that the submit button has to be blue. Or when the customer launches on my e-commerce site, and if they are logged in, we will say, hello, Tom. So we program the computer. We know either this will happen or that will happen. We exactly know what our computers are going to be programmed and what the product is going to be doing exactly as we have programmed it to be doing. But now with machine learning, it is no longer deterministic values. It is a probability that you're working on. And with that, what I mean is, now it will be something like the probability that this customer will buy my product is, let's say, 80%. If I show X number of products using a recommendation system, the probability of the customer liking the result sets, let's say, is 90%. Or let's take even a really significant real world example. Cancer and healthcare is using AI and ML a lot. So looking at an X-ray film, your ML can make a prediction that with 95% prediction or accuracy, the machine learning can predict that this customer may have TB or this patient may have tuberculosis. It's only a percentage. It's no longer, yes, they have it or they don't. So that is the kind of variables a product manager has to now play with. Explainability of outcomes. Given the data set that we have and the way machine learning algorithms run to create models, it many times become a black box on how these predictions are given. And yet another example of it is you decline a credit card holder of their ability to purchase on on an e-commerce site. You'll say, okay, as you put your credit card to buy something, the backend decisioning engine, which is running over a machine learning algorithm, will say, okay, decline this person's credit card because you don't know why they said because. The front end will just come and decline your credit card. On the back end, if it is a deep learning algorithm or a machine learning algorithm, many times getting to know why exactly the customer was declined becomes a data science issue where you go back and you need to know, okay, what exactly were the machine learning factors that went in because of which this person was declined. So how can you explain your outcomes? And then fairness, bias, and data imbalance. The data that you use may not be very balanced. It may be skewing towards one segment of people. The new infrastructure, processes, and tool. Given the AI and ML world that we live in, the AI ops infrastructure, the processes, the tools that we are using is very different than what we are used to. And then identifying the right problems to solve that creates the intelligent experience remains still a really big issue for the product managers. And hence, product managers have become so much more relevant. And some of these thoughts I've already covered on the previous slide, so I'll just run through these ones. Like, product managers have become more relevant than ever before to embed intelligence into the product. So in the machine learning life cycle, the role of product managers have become so important is that going in, you should know what sort of machine learning or AI capabilities can be used to solve your problem. It cannot be an afterthought. And then we will dig into this a little later as well, finding that right machine learning problem from the business problem that you have. How do you translate it into a machine learning problem so your data scientists exactly know what to model for? And then these problems are not easy to go to your stakeholders and pitch the return of investments because AI products take a long time to materialize. And then finally, the very important factor here as a product manager that you need to understand is, where is the data within your company? Who is bringing the data? And identifying those right set of stakeholders and groups who have the control of data is very important for a product manager. And then the most important thing remains, more as a learning thing, have have a very good operational understanding of the machine learning process. Who does what and when in the whole machine learning process. And this is what the crux of rest of the webinar is going to be. So let's take a couple of minutes to talk about data, because artificial intelligence, machine learning is all fueled by data. In the past, our traditional product problems and kind of solutions that we produced really did not have to rely beforehand on so much of data. But the AI and machine learning products are all fueled by data. So selecting the right problem also depends upon the data. And now I'll go back and I'll say, why did I have those quotes that work backwards? Find your customer experience and the customer problem that you're going to solve first, and then go find the technology. But guess what? Here there is another mix. Yes, you know the problem that your business is struggling with, and that is the problem you want to solve. But without access to data, some of your most pressing problems may not be able to be developed. So then what do you do? How do you identify those problems? So still keeping the customer and problems in mind, start with the teams that already have the training data available and help them drive their most important metric. So it's still keeping your customer problem or your business in mind, but start with the teams that say that, yes, we have the data, we have collected the data, and then find what problems you can solve. And typically, the teams that have the data and have some problem to solve, they are also aligned with the larger company priorities as well. So you wouldn't be shifting the principle of solving for the problem that ties with the customer objectives first. And then another thing that is also overlooked many times is leveraging the ML platforms. There are many companies that already have the ML platforms and capabilities. See what platform capabilities and features are already available on your AI platform within your companies that you can use to enable these products. So there can be low-hanging fruits where you can take the capabilities that your company already has off of an ML platform and build on top of them. Or you can influence to build capabilities on on the ML platforms based on the product that you want to launch. So talking about data, this is another very important thing that a product manager needs to keep in mind in the whole machine learning workflow. Where is the most time spent in data science? Many of you, I'm assuming, may already be aware, but it's never enough to emphasize the fact that the most amount of time a data scientist spends goes in data wrangling. So in this donut wheel, the orange part, the 60% and 19%, it's really the cleaning and organizing and getting the data that takes 80% of your time. And then it's only 20% of the time that is spent on the actual building of your model, training the data sets, testing, validating, and uh, refining your models. But still, the maximum amount of your time for any data scientist is spent in the data wrangling life stages. So what does this mean as a product manager? What it really means is then, as a product manager, it's extremely important that we know the data very well. And this is where your role as a product manager then creates a bigger impact in that whole machine learning life cycle. Okay, with that foundational thing about where is your most amount of time spent, how do you find the right set of problems, let's get into the machine learning anatomy. And this is more to set up the rest of the webinar. Machine learning problems can be classified into unsupervised learning, supervised learning, and reinforcement learning. And then within the supervised learning category, we have we have regression techniques, and we have classification techniques. On the unsupervised learning side, the way the computers work is they say, okay, the computer will say, I've just have some sort of example there, that the computer's mindset is the computer is self-sufficient. Just give me lots of samples to train myself. And me here is the computer. The computer is saying, just show me tons and tons of data, and computer will find patterns from it. On the reinforcement learning side, it's about my life, my rules. Think about robots. It's a hit and trial where the computer says that show me the data and I will learn from hit and trial, reward motivated scenarios. Where if there is a robot that is going towards a wall, if it hits a wall, it will get a negative feedback score and it will train itself that, oh, when I did this, a negative feedback score was given to me. But what happens in the supervised learning space is the computer is expecting you to give labeled data, and then the computer says, give me the label data and use an algorithm or model to train me, and I will learn. The computer will learn to give the best prediction. And that's really the crux of supervised machine learning, which is really the foundation of also unsupervised or reinforcement learning. The whole life cycle still remains the same. Give me the data, show what you want to predict, and the computer learns on data to make the best predictions. So in this course today, I will, or in this webinar today, I will be going over the whole data science workflow. That's what it is all about. And now talking about data science workflow, if you Google data science workflow, you will find many different variations of the life cycle of workflow. There is this awesome, yes, it's awesome, OSEMN data science pipeline. That is about obtaining data, scrubbing or cleaning data, exploring and visualizing data. M I have highlighted here because that is your model building, the machine learning models coming in, and N is interpreting data or communicating your insights. If you see this data science workflow is really the master set of your workflow. And within that, machine learning, true machine learning, really starts with building the model. So, but then what was the steps before that? It is that 80% of the step of cleaning data and organizing your data. Now, not to say that machine learning engineers or data scientists cannot do the or does not do the whole data wrangling step, which is this import, tidy, and transform. This is just a simplistic version of it. The reason I'm showing this here is this particular life cycle stages, as a product manager, you may be talking to a data engineer or even a machine learning engineer, but many companies, almost 80% of the companies have this role of data engineers, or even the traditional engineers who are very familiar with data. They will be spending the time on importing the data, cleaning the data, transforming and normalizing the data before it is even ready for machine learning algorithms and models to be run on that data. So this stage in many companies, especially in larger companies, you'll see different set of teams working on this life cycle. Now, there are these terms about machine learning engineers, and that's where the machine learning engineers could come in, that when the data is ready, they will have the different algorithms that they will try and build the model and all that fun stuff. So let's get deeper into the supervised machine learning process. This is yet another depiction of that same process that I showed using the OSEMN model. But to me, this is the more simplistic version, and more or less 99 or 100% of a supervised machine learning would have these steps. And the goal here is to go through each of these phases and identify what is the activity in this phase and what is the role of machine learning, what is the role of product management in this machine learning life cycle. First, what are the different steps of this machine learning life cycle? The first four are defining the problem, importing the data and data wrangling, splitting your data to train and test your model, and selecting the features which are important for your model building. The reason I have highlighted it in the green box, the top four, is this is where the product management should absolutely be involved with the data scientists, with the data engineers or machine learning in lockstep in all of these four stages. Many times that I see in the industry as I talk to a different data science group or different AI groups, the tendency has been that the data scientists pretty much run through all these steps, which is fine. But what the product managers should be doing or ought to be doing is finding a voice in these life cycle stages and helping and guiding the data scientists on what is the right problem to solve and what is important in that data set that you have that will create the best model. And this is what I will go over in a little bit more in detail. Then the other three steps, training the model, making prediction from the model or the predict stage and evaluating the accuracy and pushing it live and maintaining it. The rest of the three steps are heavy where your machine learning engineers or your data scientists will be in the driving seat. Today, almost all these seven stages are also run by data scientists in many companies, but then where it breaks down is not in all company, there is no generalization here, but it's an observation that that industry is coming to realize that there are many companies, a ton of investment in data science, big groups have been formed, ML platforms have been launched, algorithms and applications have been written. But what is missing is companies don't know where to use that machine learning applications or features or capabilities that have been built. What problem is it solving? So we have all these little nuggets in the companies on an AI platform, but the companies are still suffering to see the value from that. And that is because upfront the definition was not there. What problem you are solving? So that's where we have to get into this thing about where and how can product managers solve this issue. Okay, so let's take each of these stages one by one. Define the problem, target variable. What is this all about? The role of product manager in defining the problem stage is identifying the right problem that the business cares about and defining it in terms of a machine learning problem. And I will get into that in a little bit. What do I mean by defining it in the terms of a machine learning problem? And then the third thing that a product manager should be doing hand in hand, by the way, these are not sequential activity. This is your role. So this should be your mindset. Deep dive on the subject matter. Whatever industry and domain you are in, once you have identified a problem, do more research on the subject matter, become the domain expert. Product managers are already the domain experts, but you need to continuously be enhancing. What else do you need to know about that subject? And then prioritize on the criteria and prediction accuracy. This is nothing but saying, as a product manager, knowing the business and the industry, that if you're predicting for a traffic pattern, as a domain expert, you can say, even if we have data about color of the cars, that doesn't really affect the prediction accuracy of traffic. Seems common sense, but then extrapolate it into a healthcare industry where you have to predict cancer. It's not your data engineers or a data scientist who are the domain expert. You, as the product manager in the healthcare industry, will know what are the criteria, what are the variables that affect heart attack, that affect cancers or tumors. So you need to prioritize the criteria, you as the product manager. And then really defining what is that is being defined, define the target variable, which is the machine learning problem. Then on the right, I have just put a sample of what are these machine learning problems that you can solve for. So double clicking on this thing about defining it in terms of machine learning problem, I just have a snapshot of what a data set could look like and what and how a product manager can come in this stage. So now remember that donut wheel or the life cycle, that 80% of your time has been spent in collecting the data. And that, imagine 80% of the time is done, and you have now this patient data in front of you, where you have age, sex, cholesterol, cigarettes. Each one of this is a patient. And what you need to do is your job as a healthcare industry. In the healthcare industry, you are a product manager and you are helping your data scientists like predict whether this patient who is coming in this hospital has a higher likelihood of getting a heart disease or not. How do you go about that? So you have this data. What you do is you first identify the problem. The problem is find out if a new patient is going to suffer through a heart disease or not. So your target variable is your heart disease. So this is about, in the previous slide I had, identify the target variable. So now that you have a problem, identifying whether someone has a heart disease or not, turning it into a machine learning problem becomes that, okay, we'll say, okay, we will focus on this variable, whether somebody has a heart disease or not. I'm going to go a little bit faster given the content here. So if you have any questions, please place it in the chat. So now once you have the target variable heart disease, as a product manager, you work with your data engineers business in identifying what is it that you're going to predict. You also make sure that the data that you have is labeled. And this is where product managers, you may work with data product managers, you may work with other sources where the data is coming to ensure that the data that is coming is labeled. And I'm not going to get into data labeling, it's a whole industry of its own, how and where the data gets labeled. But for supervised machine learning, you do need your data sets to be labeled, where each patient, the target variable is labeled as true, false, true, false. What does that mean? It means given these characteristics, the patient is likely to have a heart disease. Given these characteristics, the patient is not supposed to have a heart disease. So this kind of data, if you collect over, let's say, 1,000 or 2,000 patients, run a machine learning model on it, and then your model is ready to predict when a new patient comes and you input the same characteristic and run the model on it, the model will tell you, okay, there is a highly likelihood that this female age 63 has high cholesterol, could have a heart disease. So that's really is about identifying the problem and turning it into a machine learning problem. And these rows are all called observations or examples. And then another important terminology here is each of these characteristics or feature or characteristics of variables or columns is called features. Feature engineering is a very important step in machine learning. So when people talk about feature engineering in machine learning, all it is about is working with these characteristics that has a heavy impact on your target outcome. How can we fine tune these features to give you the best prediction, which means how can you work with these characteristics to give you the best prediction. So these columns are all the features. So once your model is developed and you have a new target record, a new patient coming in, you don't know whether this person has a heart disease or not. And after a trained model, you feed this data set through that model and you get a prediction. So that was the defining the problem stage. What happens in the import data and data wrangling stage? And just once again, as a reminder, the data wrangling stage is the 60% of or to 80% of your total time. So there are two parts to it, importing data and data wrangling. Data wrangling is the term for cleaning, removing redundancies, processing your data. Going back to importing data, extremely important step for product manager. What data is needed? Where is the data coming from? Do you know who in your company will provide you all the data? And then you collaborate with the data engineers to merge all that data into one source. And then how much data is enough so precious data resources are not wasted? I cannot emphasize enough how important this is as a product manager for you to have a voice on the table to say, or even to question. Let's say a data engineering team is already collecting and building these gigantic data lakes, which every company has done. But now the industry is also realizing, why did we collect all this data? Fine, you collected all this data. But now, how much data is enough for you to run your model? Data scientists will say, okay, yeah, get all the data, get it all collected in one particular source. But you as a product manager can say, if I have to predict traffic patterns, I really don't need the like how many people are traveling in the car. I don't need the colors of the car. I don't need the make and model of the cars. So this is where the product manager can come and influence the this data life cycle stage. And why is that so impactful? Because the less data you collect, the more you are helping the project in terms of cost and time. Because collecting data and storing data costs money. So this is where the product manager should always have their ears and eyes open on, like, why are we collecting all this data and how much data is enough data? And once you have collected that data, and this is what I was going over, removing redundancies and or removing extra features. Extra features here is color of the car, who owns the car, is it a male or female who owns the car? We are in the industry where all of us know in today's world, every single bit of data is getting collected. But how do you remove the redundancies? Like removing inaccuracies. A lot of data sets you will see that is just inaccurate data or data is not provided. So having a good understanding of what data should be deleted, what is the inaccuracy that should be purged, the NAs like not applicable values or null values, all of this while it is actually executed by data engineers, product managers should be eyeballing that data and working through with the data engineers to say what should be removed, what should be kept. A very important step here also is many times you will say there are some null values or not null or NA or not applicable, whatever. It's not always a good idea to remove it also. And who will make that decision? It is in lockstep with the product managers, because when you're removing a lot of data also because the value, not all values were there, you're losing samples also. So there is an art and a science there. And then conducting the exploratory data analysis to know how that data will be looking when you plot it on the graphs or you create these visualizations, which is again out of the scope of this particular webinar. But visualization of data and exploratory data analysis is a very important step where you can see a lot of skews in data, a lot of, extreme exceptions in data and abnormalities in data is very easy to spot when you do visualization. Then the third step in this life cycle becomes the splitting data. So now you have gotten all your data, you have removed all the redundancies and your data is ready. As a product manager, you need to work with your data scientist to say, okay, how do I split my data into training, testing, and validation set? And this is a very important concept in machine learning, or a very important phase in machine learning models. When you have the data, let's say in this picture, this is a pretty good picture actually. Let's say this top row is your data from your life system. You have all this data. What you will do is you will say, okay, and let's say on the topmost itself, I am taking 60% of the data or 70% of the data to train my model, and I'll keep 30% to test my model. And a good example here I give all everyone to everyone who has not been exposed to this concept is, think about how we did math problems or got ourselves ready for math problems back in our school days. We will always practice on, let's say, on the odd number of problem statements, and we always had the answers for the odd problems. But then once we have studied our math concepts, we will practice it on the, or we will test our understanding on the even numbered problems. So this is similar concept here, where you take your data set, you train your computer on one set of data set. When your model is trained, you run that model on the test data set and see what is the accuracy you're getting. Because if you're training and testing on the same data set, you will get 100% accuracy, which will be called like overfitting or underfitting. And there are many, many ways to create these data splits. And this is where the product manager will come in a very yeah, beneficial for the machine learning engineers. Whereas as a product manager, you can say the data split that I want is by the time, where every other day can be for testing data and every other day can be for training data. On the other hand, as a product manager, you can also say it's totally fine. We don't need to do a even odd split. We'll just take a random sample of 70% and 30%. So these are some of the ways product managers become very important in this life cycle. Now, one other thing about balancing of data where product managers become very important is, many times, let's say you're trying to predict if somebody has cancer or not. And in the data set, you see that 70% of your set is for samples which are benign, and only 30% is for malignant. You already know, okay, if I train my model on something like this, it's going to be skewed, where it will say, okay, it is benign. So how do you help your engineers in creating that data set, testing, training, and validation data set? So it's an even split, even going in for training, where you say, okay, we'll only take 30% of malignant tumors and 30% of benign tumors, so that my data is balanced. So this is the kind of things that product managers need to do in these life cycle. And then feature selection, one of the very important stages, as I was talking about earlier, is all about showing your domain expertise. PM, this is the phase where product manager is most needed and can have the most impact given their domain knowledge. PM knows the business, the domain, and the data. PM will be the most important resource to inform ML engineers on which features are most necessary for predictions. And this is where the data scientist stumbles the most, because they have built their data repository, the data is ready, they have the splitting and testing and training validation. Now they are ready to run their models and train the model. uh, and they are stumbling with, okay, what feature set or what features or what data is the most important to make that prediction? If the data scientist is from the industry and they have this knowledge about the healthcare industry or industry, like predicting traffic, you may think it's a common sense, so most people will understand. But when you get into more complicated scenarios, let's say predicting the stock market, as a product manager, you have the understanding to say, these are 3 or 4 features which will make the most sense for the prediction to be accurate. And this is also the life cycle stage where product managers can say that, given we have, let's say, 30 features, and many times the models may run on like 50 and 100 and like thousands of features also. There is no um, set rule how many features your models is going to take. This is where you come and say, okay, I see these features that can be consolidated into one feature. For example, if you are creating a sales pattern for a big mart shop. And you'll see that there are different features where one of them, the value, and this is a global company, global supermart. And in Europe, the same, the weight is in kilograms. In US, the weight is in pound. And in some other place, the weight is, let's say, in ounces. How do you take all of these three features together, normalize it, and create one feature? Then another feature can be big store, small store, medium-sized stores. And every country, every geographic location has defined it in a different way. As a product manager, you'll come and you'll understand the data, consolidate it into one. So those are the kind of things that happens in the feature selection phase, where you're imputing data, you're missing data, your feature engineering, everything goes in this phase. Very important one for a product managers to come and help the data scientists to come up with the right set of feature selection to build the model. So the top four is where managers role is really heavy in helping the data scientists make the best prediction, or to help them get ready for these two phases. Now, training and predict phase is where the data scientists get in the driver's seat. Primary role in this phase is data scientist, ML engineer to train the model to make prediction. Product manager becomes a supporter who collaborates with ML engineer and data scientists to help them answer any question during this predict and train phase around data or domain. In this phase, the activities that take place is the data scientists will come up with various algorithms and try to identify the best algorithm to train their data on and produce the best model given the prediction uh, uh, given the prediction benchmarks that may have been set early on. And early on, the product manager and the business and everybody together, all the stakeholders together would have said 95% prediction accuracy to detect if a person has cancer or not is acceptable. Anything under 95% is not acceptable. Or other, for something very acute where there is even further implications for life and death, it could be no, nothing less than 99% accuracy. So these kind of prediction has to, the benchmarks have to be set ahead of time so that the data scientists in this stage find the best algorithm and models to train their data and get to that accuracy. What does the product managers do? This is where the product manager is now on the back seat, but still collaborating with data scientists for acceptable accuracy and prediction thresholds. And then whatever the insights comes, they are always like, now it becomes like, a feedback loop where, okay, this is the model insights, you work with your stakeholders, you even can always confirm if it is validating your business case or not based on the accuracies that you're getting from the training phase of building the model and predicting the model. So this is an ongoing phase where this is a development phase of your machine learning models. And then based on that kind of a ongoing feedback loop where you're fine tuning your models, you're tuning your hyperparameters, you're coming up with the best model based on the objectives that were defined in the first stage. You continue to evaluate the accuracies of your model. And this is also done by data scientists and ML engineers who are continuously improving the and fine tuning the model performance. What is the role of product managers? This is where the product managers, in lack of a better word, you can become the testers or the business acceptance testing to test the models. You're constantly bringing new set of data, new live data, and helping your data scientist test your model. The two other phases that I have not put in here because that becomes more like an operational model is, of course, your model is developed, it is accurate. How do you deploy it? Then that is where the machine learning ops and AI ops team, just the traditional DevOps, AI ops, all these new names are coming up in the industries, come in and push your model into the production. And the phases that goes on the activity that goes in there is when you're pushing it into production is all about, are you versioning your model? Can your can you explain the predictions, how it happened, the explainability of your models? So there is a whole model management life cycle that goes on when you're trying to push your model into production. When new data comes, you retrain your model and you repush the models in production. So how are you versioning? How are you keeping track of what were the data sets and variables that went into the fine tuning of the latest set of model? All of that goes in the machine learning ops and AI ops life cycle, where more and more product managers are not in the most like it's not the primary activity of product managers. But yes, if you're fine tuning your model, new data, new feature sets come in, it kind of goes back to the round one, which features are important and all that. So that was really the crux of your 7 steps of the machine learning life cycle. And just to recap, in ML product management, solve the right customer problem using AI, and always identify what does your customer care for, and collaborate and influence the data scientist as a product manager by sharing business objective and use cases that can be delivered by AI. Data, absolutely the biggest change that has come in the industry for product managers is whether or not you have had a chance to look into your data carefully. And this data is not post launch data of what your customers are doing, it is the data for your domain. Know your data well. Only then you will be able to come up with new set of problems that can be solved using machine learning, and know how to prove the return of investment on your data. And then finally, this is just a general recap of continuous learning of ML, AI, and data science to be abreast with the changing nature of the technology. And the reason I wanted to put this one here is what I showed you is a supervised machine learning data flow, which is more or less the same set of steps in unsupervised learning or deep learning also, except deep learning does not have feature engineering. But every kind of machine learning is so different. How and what NL, like how clustering algorithms run, will be so much different than how regression techniques are run. So a run or what they can deliver. So just doing ongoing reading on different kind of things that machine learning can do will help you come up with the right set of problem statements. So that would be my recap on this particular one. With that, that comes to an end of my webinar. I know there's only a few minutes left, but I will hand it over to the organizers.
Thank you for the wonderful session, Mamta. Really great insights. And as you can see, we already have questions lined up for you. So we'll take as many as we can in this 2-3 minutes that we have. So
Sure.
yeah, I will read the question, but meanwhile, you can also check it in the Q&A window.
So the first one, yeah, is AI. Yeah,
Yes.
do you
So
want
the
to read?
first one is AI knowledge in all mandatory for a product manager? Do product managers need to be coders for building AI products?
Excellent question. So the second one, no, you are not supposed to be a coder for building AI products. And now that said, building AI products, also, if you remember the life cycle, the coding part is really in building the algorithms, which is used to train the model. So there are different levels of coding, but PMs don't need to know the coding part, or they don't have to be the coder. But knowing these 7 steps is very important. And what I would urge you to do, or all of you, is just take these 7 steps and just Google and see what are the activities. Just knowing what activities are there is a good starting point. Now, getting to the coding part, in the model building part of it, even there, the code part is pretty small. Where the code part is intensive is where the PhDs of the world come in, and statisticians, is writing the algorithms and creating the algorithms. And it was out of scope here. There are two parts to that building a model. There is an algorithm, which are already published in the industries, Google, Amazon, all these Facebook, all of these big technology companies have come up with algorithms and open source algorithms, tons and tons of open source algorithms. So that part is already done. You take those algorithms, bring your data, write like 20 lines of Python code or R code, and your model is ready. So no is the short answer.
Right. So let's take the next question. This is from Zabiullah. As AI is getting into every digital product and essentially will get into physical products with the embedded sensors or IoT, do you think traditional product managers should learn AI and machine learning, or do you think AI professionals should get into product management? Which of this direction do you think will fill industry gaps in talent more faster?
So to rephrase this question, or not rephrase this question, just to get to the crux of this problem, Zabi, the thing is, AI professionals should get into, who is an AI professional? So let's say, okay, so the way to explain this is, there isn't an AI professional getting into product management thing. It is product management learning AI. And I hope it was a little bit clear. What I was saying is, in my webinar is, you are already a product manager, let's say, or you are, even if you're an engineer, and you need to, you said IoT. IoT is also going to use AI. It's just in a physical product. And what I mean by that is, you're a product manager, and your problem is now to say, let me come up with the IoT example. Yeah, your product is to say, control the temperature within a particular house. So how would you go about it? You will say, okay, there is a thermostat in my house, which has a sensor and which is continuously transmitting data. And as the data is getting transmitted to you, so by the way, so far there is no AI yet, and I'll tell you how these things are connected. So there is no either or answer there. So there is a thermostat in the house, there is a sensor that is sending data to the cloud. All that data is getting collected, and the data is getting collected. And this is the first 3 steps of collecting data. Data collected was, what is the time of the day, how much data was used, what is the temperature, how many people were there in the house, and everything is getting collected by the sensor. All of this is collected. And without AI, you can say, okay, the temperature will be down between 8 to 5, and temperature will be up between 5 onwards, because that's when people come back from office. No AI here. It was only IoT and sensors. But where can AI get in here is, once you have the data, the AI will say, okay, it has been detected that 2 hours in the morning, a pattern, a computer detects a pattern that 4 hours in the morning and 2 hours at night, that people are there in the house. So that is when automatically temperature should go up. How can you do that as a product manager? Because you have some understanding of AI, that you know what is possible. So the way to answer this question, it is not about AI professional going into product or product doing AI. It is, you are a product manager who can solve a problem, and then you should know what technologies are available to solve that problem. So I guess this question itself doesn't make too much sense, because there isn't any AI professional as such. Because in that life cycle, you saw there is a product manager, there is a data engineer, there is a machine learning engineer. So every different role plays a different role in that life cycle.
Right. So, Zabiullah, I hope that answers your question. And let's take this next question, Mamta, from LinkedIn, one of our viewers from LinkedIn. So this is Bharat. asking us the ML modeling stages are exploratory in nature, hard to time box. So how do we fit them into Scrum iteration?
Which was the question? So before I take that, I do want to also finish one more thought about Zabi, where you were saying should product manager should learn about AI/ML. Absolutely, you need to understand the industry. It's nothing different than if you are a product manager and you have to develop a mobile app now. So you need to understand the native features of a mobile phone. Okay, so that's where I'll stop there. So Bharat's question, I'm trying to look. Can you repeat that
This
question?
is actually this
Yeah.
is from LinkedIn viewers, one of our viewers, so you will not be
Oh,
able to
okay.
see it in
Sorry,
the
go ahead.
Q&A. I could repeat the question. The ML modeling stages are exploratory in nature, hard to time box. So how do we fit them into Scrum iteration?
Oh, okay. A great question. So if you uh, remember, so Scrum iteration, I would say, and again, there is no right or wrong answer here. I've seen everything, every different kind of approach. Take each stage of that whole journey and create scrums for that particular phase and activity. For example, let's say you're talking about model building. One of the scrum could be before the model building. Let's start with data. One of the scrums 2 weeks sprint session could be that in the 2 week sprint, we will do data normalization or data redundancy and data processing. So we create those sprint session for that scrum, and different set of people will be involved, different set of scrum masters will be involved, because this is a data engineering thing, totally kind of sometimes even independent of what rest of the data scientists are doing, because those sprints can involve get your data from customer management data warehouse. Other scrum team could be for the model building phase. You could have your own scrum and sprint session where it says in this scrum team there will be a data scientist, there will be let's say a machine learning engineer, and these in 2 weeks sprint session we are going to come up with 3 possible algorithms that will help us to build models. So in short, I can say within the time constraint that we have here, consider having scrum based on each individual phase that you're going through within that project. It is very dynamic. The kind of people you need is very different. So it is a very, it's kind of an evolving scrum approach there.
Thank you for that, Mamta. We'll take this next question. I hope you have the time for that. I
Yeah,
know
I
we are
have.
running short. Yeah, we
Sure,
are
sure.
having some
No, no.
really great interaction, and I don't want to miss out on that.
No, no, I do
So,
have a few minutes more. I can.
sure. Thank you. So, this next question is on your point of how much data is necessary, what should be the product manager's stand with the data team?
How much product is necessary? What should be standard? So there are three things here for data. One is what data is necessary. So product manager has to come up with that. Okay, these 10 features are absolutely necessary. We have to get that. How much data is necessary? There is no science or calculation behind that. And this is where you collaborate with your data scientists or machine learning engineer. Of course, everybody will say more data, the merrier. But if you also Google and try to read, the best models are created on least amount of data. What it means is if you have the right set of feature and right number of data sets, you can create your best model. More data does not necessarily equate to better model. So to answer your question, how much data is necessary? There isn't a hard and fast answer. You always start with, let's say, how much data is available. Not always start with, but one of the approach could be how much data is available. And you can say for some a problem, like you'll say, oh, we have 2 gigabytes of data available. You'll already like, no, probably this is a lot. Let's figure out what set of data, how much data we take. Now here you get into then the next level. Oh, I'm very lucky I have 2 gigabyte of data available to train my model. You'll say, okay, let's create the best data set combination that it covers all geography, all the different, like it's a very diverse data set. So the data that you're collecting is has sample of everything that you need to train your model. So to recap, how much data? There is no hard and fast answer, but how do you get to that answer is, if you have a lot of data, how do you create a data split of that data that you have so that it has a sample of all different kind of data sets that should be there.
Well, in continuation to that, Mamta, the next question is also any best practices on what percentage of accuracy is good enough for product managers to set expectations during the life cycle of machine learning?
Yeah, a very good question here. So there isn't a best practice, right? Because let's talk about it. And I'm thinking on the fly of example. It depends on the problem statement. Let's say, once again, the cancer, you're writing a model to predict if somebody has cancer or not. The accuracy better be in high 90s. At the same time, I'll take two more examples, right? Traffic prediction. You have to go to work or to the hospital, wherever. Traffic accuracy, it's okay if you can get me around 85, 90 also. It's fine. I will not be very happy once in a while the traffic pattern is not per what I was told. Or then come into, let's say, recommendation engines. Well, these days recommendation engine is high on accuracy also. You may be creating another set of product where accuracy in 60 to 70%. Stock market prediction, nobody, like anybody who says we can predict stock market with 90% accuracy, I don't know. Probably their accuracy is like 75, 60. So it really is driven by the problem that you're solving. So, okay, so now what you can then do is, once you know your problem, do your own research. This is very important. So let's say you are in cancer or research, or you are in stock market prediction. What you do ought to do as a product manager is do your own research, Google, to see in that industry, what has ML algorithms been able to predict for? If the stock market accuracies have been trending at 85% accuracy with the best algorithms, then you aim for 85%. Then it goes down to, okay, what is the technology able to give me? If in today's world, if technology is able to give me 85% accuracy for a stock, you should aim for that. Next question.
Right. So how about we take two more questions, Mamta?
Sure.
Right. So we'll take this next question from Bala Subramanian. Is it possible for product manager to play a role of data scientist as well as during train the model and prediction stage, since product manager is involved in the initial stages of identifying the problem till feature selection? It was a long one, but if you can check it out in the Q&A
Okay.
window.
So this is, no, I'm reading. So it depends. Many companies today are hiring product managers. Many companies, especially the larger one, the tech companies, are hiring highly technical PMs who actually have engineering background. And if they can code simple Python, they can build a model too. Now this goes back to the first question, do PMs have to be coders? You don't have to be. But if you have the skill set, and if your company allows you to play that role, by all means, go ahead. Like, I'll tell you something. I've been a career product manager for 20 years. I started off with a master's in computers. So I knew how to code, but I had forgotten about it. But in the last 2 years, given how easy it has become to code with Python, I rolled up my sleeve and I have been I have been building models. But so I'm doing end to end. I'm using, and you can use any IDE, and you can use R or Python, simple language, Google Colab. So you can do all of these things if you have the coding skills. That said, just taking my own example, I can do everything what you're saying here, Bala, but I cannot build an algorithm because that requires statistics, that requires extreme like math and stats and very advanced level of whatever thinking. So it depends. One, does your company allow? Second, do you know how to code? And pretty much that. But it really boils down to, if you have a data scientist in the company, are you taking over their job?
Right. Before we move on to the next question, a gentle reminder to the audience, please scan the QR code on the screen for a 30-minute session with our faculty. And Mamta being our practitioner coach, please book a session with her for any further questions. And guys, IPL always focuses on learning by doing. And it's always facilitated by global faculty who are practitioners, like we have Mamta today giving us her insights. So for any more discussions like that, please scan the QR code and get answers to your queries. So one last question, Mamta, this is from Vijay. How to make the choice regarding what sort of data splits make sense, work for which problems and data sets and under which context? Any general guidance on this?
Yeah, sure. The simple answer, Vijay, to this is a lot of automated ML platforms today even give you um, tools to split your data. And you can even put in, do you want a random data split, or do you want a time-based data split? So this data split part has become truly automated in almost all these automated machine learning platform that is available. Now, what is the choice regarding what sort of data split is kind of similar to this percentage answer. It depends upon your domain also. For for example, a weather related domain where I'm going to do some weather prediction, I personally would like to see a data split that happens based on time. So rather than saying the first 60% and first 80%, time-based data split, or um, I'm forgetting. Either it's a time-based data split or, okay, I was just going to say something about weather. So yeah, the choice regarding the data split will very much depend upon domain. Now, within data splits also, of course, today was only 1 hour thing. There are multiple different techniques. There is something known as cross-validation. The cross-validation is there are packages that does it for you. You can pick a cross-validation technique where it will take every other data set, and it will do an automated data split where every row of data, I can't explain it without a visual thing. It's a cross-validation data split if you look it up. So in short, domain is definitely important, what sort of data split you do. And in many domains where it doesn't really matter what was the time of the date for make a prediction, or it doesn't matter, the seasonal nature of it is also not an important factor. You can totally use package to say, let's do a random data split. So the good thing about this data splits, there are tons of automated packages. I frankly, I don't even remember when I last thought too much about it. Like this create data partition, there is a R package, there is a Python package, and you simply put 80-20, 70-40, and it creates those splits for you. Then there is a cross-validation one. Then there is odd and even one where you can simply create odd and even set of data for testing and validation. And
Thank
to
you,
answer your
Mamta.
question,
Yep.
which problem data sets under which context? So that is the context here, depending upon what domain you're solving it for. you need to know, okay, does it matter if I just take, for example, one last thing about this one, if you have data from January to December, and you said my data set is going for training, it is going to be January to September, and then October, November, December is going to be testing, just by the nature of it is not going to be a good collection, because let's say um, for clothing item, you are putting 3 winter months for testing while you have trained your data mostly on summer, fall, and spring. The time-based one is easy to explain the concept, and hence I always take that example. But what the thing to take there is, how do you use your domain to create the data split? One other thing about data split, right? Under which context, going back to cancer, is your data split going to create all males and females? Is it going to separate them? Are you creating a data split where all the ethnicity is going to be removed? Let's say you created a data set where ethnicity is all in training data, one ethnicity is all in training data, whereas other ethnicity is not. So data imbalance, data split, it all kind of ties together. Yeah.
Thank you, Mamta.
Great
And
questions.
yeah, it was a good one.
Yeah.
Thank you, Vinay, for that. And so coming to the final part of the session, Mamta, we'll need your help again here. Let me just move to that slide. Right. So audience, thank you so much for your participation. It was a great session indeed and really good interactions. So Mamta, please help us pick the champion of curiosity, which is basically the best question. And we will as an IPL will reward them with a free digital course. So you can see the questions in the answer section, and the ones which are not answered also you can have a look at it.
Wow, you're putting me on the spot. All these
You would
questions
be
are
the best judge either
good.
way. So
Let's see. They were all such good questions. I think the data split one is a good one, because there is a lot that data split one, and I'll still do second and third because I don't like just one. And I do like the one, is it possible for PM to play a role of data scientist? And the reason I like that one is not so much about the question, it's about the possibilities for you to see what can be done. And then also the very first question is, AI knowledge and all mandatory for, like, do PM needs to be a coder for building AI products? And so these are my top three. And the reason for the last one being in the top list is also because I suffered with that 6 years ago when I ventured in this field a lot, how technical I have to get. And I burnt my midnight oil trying to figure, can I become a coder? Can I do? So that question is very valid. You don't need to be a coder though. Yeah. But the data split one.
okay, awesome. So Vijay, congratulations on winning the free digital course, and we will get in touch with you shortly with the reward.
Champion of curiosity. Thank you all.
Yes, we have enjoyed having you with us, Mamta. It's been a complete pleasure. Please accept the certificate of appreciation from the Institute. And if you scan the QR code on the certificate, it will take you to a dedicated Hall of Fame page created with a recording of the session. You'll be able to view it tomorrow. And please share it within your network, and we'll share the webinar recording on our YouTube channel as well. We are grateful for the time and effort you took, Mamta, to share your thoughts and amazing insights drawn from years of research and experience in the industry. I'm certain that our audience will definitely benefit from the methods you suggested and get ahead in their career.
Thank you.
Thank you once again for joining us.
Bye-bye.